Okay. Okay, what do we do about this? What's a little different?
I don't know.
Okay, we looked at some stuff yesterday. Something's different here, though. What's different?
There's 3 terms in the box.
Okay. The bottom is not, it doesn't look like x minus k, does it? Right?
No.
It's not linear,
No.
and it certainly doesn't have the leading coefficient is not, or leading term is not 1x. It's an x squared. So the stuff I showed you yesterday does not directly apply here. The stuff I showed you yesterday, remember the synthetic division thing, in order to do that, we had to be dividing by something of the form x minus k, right? So, suggestions. Is there a way we could salvage what we did yesterday? You can't take x squared out. What do you think? Julie's got an idea. Okay, on the bottom?
Yeah.
Okay, what about the bottom? You're onto something there, kind of, maybe. What about the bottom?
Can you do that difference of cubes or whatever it was called on the bottom, you know, how they have the difference of squares?
Well, it's not a cube though, right? It's a quadratic expression. But what can you do to the bottom there? Now, bottom does potentially there's something that might work a little bit. Remember, the problem was, what if we factored it? Okay, does it factor? Are there magic numbers?
Or you do a times b into c.
Okay, and a is just 1 on the bottom, isn't it? Yeah. So okay, so positive 2, negative 3. Okay, so it does factor. All right. So let's factor the bottom. So it's going to factor into, what did we say it was? X minus 3, x plus 2. Now look at this. Each one of those by themselves looks fine, doesn't it? Right? So that's x minus k where k is 3. That's x minus k where k is negative 2. Okay? So does that help?
Can we do something
Can you just
Yeah. Okay, what about this? Now let's look at, that looks like kind of a big mess. But what if we look at a little simpler situation? What if we had something like, we had some numerator, let's just call it n, divided by a times b, right? There are 3 factors written there, aren't there? There's n, a, and b. I can multiply and divide those in order if I'd like to. I could do this as n divided by the quantity a times b, which is how we have it up here. But I could also set that equal to n over a times 1 over b, right? Which is really just the same thing as multiplying by 1 over b is just like dividing by b, isn't it? So my point is that we could just divide, for example, the top by one of the factors on the bottom, get a result, and then divide that result by the other factor.
we do 2-part thing.
Yeah, right?
Okay.
So there is a way potentially that we could make this work, right? Maybe. Okay. The synthetic? Say it again? Synthetic division, yeah, that's what we're gonna do. And okay, now and there's the thing. Synthetic division is so quick and so easy that if the bottom does factor, it's worth trying. Now, understand there's some limitations here. If we try one of these and it doesn't go into the top synthetically, it's not a factor, we're sort of stuck, aren't we? Right? Because if we get a remainder, then this is not a polynomial. We don't get a polynomial result. And we're sort of stuck and it's not, it didn't work. But it's really quick and easy to try and see if these are factors synthetically, right? So let's do that. This is good practice too. Reminds us what we were doing yesterday. So, good review. Okay, so let's make our synthetic bracket. how about if we just focus on, we'll just do this first one. We'll divide by that one
I
first.
already did it, doesn't, it has a remainder.
Yeah, it does have a remainder? Are you sure?
Yeah.
I didn't think it did. I don't think it does. Did you forget the 0 maybe?
Oh, yeah.
Okay, so what are the coefficients?
0.
0.
-2. -11. -30.
Okay, and so what number goes out front?
3.
3. Okay, so let's try this then. If I pull the 1 down, 1 times 3 is 3 plus 0
3.
times 3 plus -2 times 3. So I get 10, good. 0. So it worked, right? Okay, now I'm going to show you, this is a really good trick, really good trick. So we at this point we know that this guy divided by this guy equals that polynomial, right? So this is equal to this polynomial. So what is that going to be? Tell me what that polynomial is.
X cubed.
X cubed, okay.
Plus 3x squared.
Divided by this now, right? Okay. And so now we've got to do that one synthetically. But look, it's already built. It's already built for us. Notice that those coefficients are those coefficients. And so this is what I like to call nested synthetic division. You can just vertically continue to work down on the same, same stuff that's already built. We could just draw a new synthetic bracket here, like so. See how that works? What number do I put out front now? -2. Okay, so we'll see. Does it work? Bring the 1 down. Works. It's a factor, right? Okay, so now what's the answer then? So what's the answer to this whole thing?
X squared plus x plus 5.
Plus 5. We got it, right? Okay, do you see though that if this first one up here, if that hadn't been a 0, we were stuck, right?
So that's the final answer, X squared.
Yeah, right, that's the final answer, because then we see what we did, we got this intermediate answer, and then the answer, right, that was our first, when we divided by x minus 3, when we divided this out, we got no remainder, so it is a factor, and that's our answer. If it doesn't equal 0, then it didn't divide in evenly, okay, right? And so we'd have a remainder. Now, if the first one divided in evenly, we're okay. Then we know we're set because we're going to getting a remainder on the second one is all right. But if the first one, if both of those had remainders, if neither one of them was a factor, this would have stalled out and the strategy wouldn't have worked because I couldn't have done the second synthetic division, because synthetic division requires us to have a polynomial divided by a polynomial, right? And the first one, if I had a remainder, it's not a polynomial anymore, right? Does that make sense? Okay, so what happens, let's look at a case where it doesn't work. That's not going to work, obviously, because the bottom doesn't even factor, right? So what do? Okay, there is still a way to do these. What do you think? I mean, you guys aren't going to know the answer to this, I don't think, but what is it? It's an interesting question. The reason you can't do that, it's a good idea. The reason you can't do that is because there's not, I can't add the same number to both parts of a fraction and keep it the same. I'll give you an example. That's what we'd have to do, right? I'd have to add a number to the bottom, see what I'm saying, to make it a perfect square. But look what happens to a fraction. Let's just say I add 1 to both of those, right? If I add 1 to the top and the bottom, I would get 3/4, and those aren't equal. Okay, good idea though. No, there's nothing tricky like that. The answer is something you don't know yet. The answer is you can divide this out using what's called polynomial long division. So I got to show that to you. Polynomial long division is I'll tell you what, it's not super hard to do, but it's a long process, and you have to be organized with it. Okay, so here's how it works. Polynomial long division looks just like regular long division that, once again, when you going back to the day in grade school, when you first did long division, it's the same kind of thing you did there. The only difference is, instead of dealing with only place values and digits, we're dealing with terms in a polynomial. Okay, same rules apply though. You have to maintain a column for every power of x, right? So what's on the top, as always, is what goes inside the division symbol, right? So this is the stuff that goes into our long division symbol. So let's write this all out. Then we end up with, in here, we're going to have 2x to the fourth, no, plus 0x cubed. Right, we have to hold those places. Okay, plus. Okay, now outside I can't remember which one's the dividend and which one's the divisor. I never remember that stuff. But the denominator, the thing that we're dividing into this polynomial, on that one you actually don't have to write out the zero coefficients. You can, but you don't have to. It's just important that you do here. Here's why. Now think ahead. When we do long division, we're going to subtract and go again, subtract and go again. So we have to maintain these columns for that vertical process that's going to unfold as we keep working down, right? Out front, it doesn't matter. So out front, we're going to have our, oh, jeez. I don't know why it does that sometimes. X squared minus 2x plus 2. Now, here's the rule. Here, how do we know if we're doing regular long division? It's easy. We just ask how many times does the number out front go into the number inside, out to a certain place value, right? Here, they're not just numbers, they're polynomials. But what we want to do is we want to know how many times does this polynomial go into this one, right? All we have to do is look at the leading terms. It's always an issue of how many times does the leading term here divide into the leading term here. So in other words, you see what I'm getting at? We want to know x squared times what is 2x to the fourth? 2x squared. Now the other way of thinking about that is you could just take that quotient. So I could take the number in here, 2x to the fourth over x squared is 2x squared, right? So that's the first term in the polynomial part of our answer. What do you suppose we do when we get a number up on top? How do I know what to subtract from this, though, in long division? Think back to long division. Yeah, we got to get the remainder. So I've got to multiply this through, don't I? Right? So I'm going to distribute this. I'm going to take this guy and I'm going to distribute it to all those parts and get an answer down here. So 2x squared times x squared is 2x to the fourth. Those always have to match up because when I subtract, I want that term to go away, right? It's going to. 2x squared times negative 2x is what? Negative 4x cubed. 2x squared times 2. Okay, now I'm going to subtract vertically. Do this though, because you will make mistakes if you don't. So what really helps with this is put this thing in parentheses and put a negative sign out front. So you remember that you're always subtracting vertically. Okay, and then we just do that. So if I subtract vertically, that minus that goes away, right? 0x cubed minus negative 4x cubed is what? Positive 4x cubed. You see how it'd be easy to make that a negative sign if you weren't being careful? Okay, so you always put that negative sign out there to remind you. 3x squared minus positive 4x squared is negative x squared. And now you just bring down the rest and do what? Start over. Okay, so we'll divide out. So now, same game as before though. I want to see how many times does the leading term here go into the leading term there, right? So we'll just divide them out. 4x cubed over x squared is what? So the next term is 4x. Now what do I do? Yeah, distribute it through, right? 4x times x squared, 4x cubed. 4x times negative 2x. Good. 4x times 2. Right, now what do I do? Oh, I don't have to bring that down yet. But what's the next? What do I want you to write next? Parentheses. Subtract. Okay. So what do we get? Cancels. Needs to. You see why it has to cancel? Every time that first term cancels, you see that we're just simplifying the polynomial. It's getting smaller every time, right? Negative x squared minus negative 8x squared is? Good. Positive 7x squared. 5x minus positive 8x. Bring down the negative 1. Start again. Okay, so, new color here. Let's go green. All right, so now I'm going to divide inside leading term by outside leading term. 7x squared over x squared is what? Okay, right? Agreed? Okay, distribute that through. 7x squared minus 14x plus 14. Now what? Subtract. Okay, and what do we get? Cancels. 11x minus 15. Okay, can I go further? Can't, can I? 11x is not divisible by x squared, right? So we're done. So what do you suppose that is? The remainder, right? How do we also know we got to the remainder? Well, as soon as we get down to a constant, that's got to be the last term in that polynomial, doesn't it? So we know we're done. We just got to find the remainder, right? You'd kind of have an idea, yeah. Yeah, you would. There might be fewer. If everything subtracts away, I mean, you know, maybe you can do it, maybe it's quicker. But we could have anticipated that we were going to have at most 3 terms, right? So how would I write my answer then? 2 parts to it, aren't there?
So that top part, and then you have 11x minus 15 over the divisor.
Yeah, good. Okay, so we can write this same as before. We're going to write this as a polynomial part, so let me get rid of this.
Can I just give us back what we had? Because I thought we wanted to get rid of the bottom.
Well, we did. We wrote, see now this is different. This is a rational function here, right? So we wrote that rational function as a smaller polynomial plus some other remainder term, right? So it is in a different form. It's not, notice that let's compare the answers when we write them down. So we end up with this answer. So we get our 2x squared plus 4x plus 7 plus our remainder of 11x minus 15 divided by whatever our denominator was, right? That's how much is left over the denominator. Right, that's the part that didn't divide in equally. Okay, make sense? Okay? And once again, you might ask yourself, well, why do we do that? There are reasons to do that. It's nice, like if we were looking, for example, we wanted to know what the end behavior of this function was. Well, we would know that as I took the limit here, as x approached infinity, this term right here, because the bottom, we'll talk more about this later in the year, and especially in calculus, because the bottom has a bigger power of x than the top, as x gets really big, positive or negative, that whole term would disappear. The fraction would get a huge denominator that would dwarf the numerator, and it would go away. And so we could just eliminate that if we're looking at end behavior, for example. And we just get this parabola. Okay? That's one application of why you might do this.
Is there a way to, like, finish through, like, the?
No, you can't, you can't go any further. That's it. That's as far as you can go. Well, I mean, you can make it look different, but you can't do anything inherently better than that. That's how that's done. Okay, so last issue then. So that's it. That's 99% of, I mean, that's, if you can do that, you can do everything in this section. I would say that's probably the single hardest thing to do is a long division problem. Because there's so many steps to it. But it just takes a little practice. There is something interesting that we can do though. Up here, I've made a couple of these already. Let me pull one of these up. Okay, how are you going to approach this one? Let me grab a picture of this and we'll talk about it. Hey, don't be throwing stuff back there, please. Okay, how we can do that? Okay, this is one where if we just tried to factor this polynomial directly, it's not going to work. What's the only way we would know how to maybe solve that equation? How would we try to factor that as of like yesterday? Say it again. It looks like, well, -2 would go into everything.
I was meaning that.
Oh, okay. Yeah, just forget that for a second. So we could factor out a greatest common factor. We'll be left with a 4-term polynomial. How do we factor those? By grouping, but it's not going to work. Grouping is not going to work on that one. Okay? So we would be officially stuck if we didn't have a little bit of extra information here. We're told that -3 is a 0 of this polynomial. Okay? So what does that tell us then? How does that help us? Okay, so if -3 is a 0, what's the factor that goes with that 0? So that's the 0. That means there must be a factor. What? What factor would we solve to get the answer, -3? See, -3 is a solution, isn't it? That's what they're telling us, is that if we set this whole thing equal to 0, -3 is a solution, right? That's what it means to be a 0, right?
So, -3.
So x plus 3, right? X plus 3 has to be a factor of this thing if x equals -3 is a solution, or 0, right? So then I know at this point that -2 x cubed plus 8x squared plus 30x minus 36 divided by x plus 3, well, it doesn't equal 0, but I know that that's going to work. That's going to divide it evenly, isn't it? Right? Okay, so synthetically, I ought to be able to do something with that, right? Now, there still is a common factor on top, isn't there? Right? I can take out a -2, and I should do that. Okay, so we could write this then as -2 times what?
X cubed plus, no, minus 4x squared minus 15x plus 18.
18, okay. All over x plus 3. And that -2, I mean, I could just, I wouldn't divide the -2 apart. I would just divide these two things now, right? Agreed? Okay. And I can do that how? Synthetically, sure, right? Okay, so this is gonna be quick and easy. We can divide this synthetically and it just looks like this. What are my coefficients?
We get 1, -4, -2, 18.
What goes in there?
Zero.
How come?
We already know it's zero.
Because we know it's a zero. Yeah, right? Oh, -4. Thank you. You're right. Okay, what number goes out front? -3. That's a zero. That produced that, didn't it? Synthetically, if I do the work here, I just get a 1, -3, -7,
It's gonna be 6.
21, 6, -18. Okay, so that tells us then that this is equal to -2 times all that stuff just became, what, x squared minus 7x plus 6, right? Okay,
That's pretty awesome.
so yeah, so that's pretty good, right? We can do this now.
A lot happier.
Say it again.
You'd have to multiply the -2.
No, because remember, the instructions say on this one, they want us to factor it completely,
Oh.
right? So we're trying to break it apart. But where would I go from there?
-6 and -9.
Okay, good. And so really, by dividing this, I want you to see something else here. By dividing this, what we really did was we found out what the other factor was that we multiply by x plus 3 to get that, right? In other words, algebraically, if I multiplied both sides by the quantity x plus 3, I would get the original problem, -2 times x cubed minus 4x squared minus 15x plus 18 equals the factored form, -2 times x squared minus 7x plus 6 times x plus 3. And now all I'd have to do is just break that apart by factoring. But that's quadratic, so it's easy, right? Make sense? And so our final answer would just be -2. What were the numbers again? -6, -1? That's it, right? Okay. So you see there how that synthetic process whittled this down to where it was pretty easy, right? We didn't even really have to write all this stuff down, did we? We knew that because -3 was a 0, we already knew that that was going to be there. That's a factor. This just gives us the other factor, right? Does that make sense? So we could have just written it immediately, just like this. We could have gone right to this form, right there, couldn't we? Here's the factor that we get from this guy. Here's the factor from that guy.
And that's all we need anyway, because we already know the x plus 3 and the that.
Right. We just needed to get this one down to here so we could break it apart. Make sense?
And that one will factor because that's what the equation wants us to do.
Now, it might have been that that one didn't factor too. Then we just would have been stuck, there. Right? Make sense? I think. Is there anything else? Okay, one other one I want to give you. This, if you can do this, you're great. You're in great shape here. So how about? Okay. want you to find that missing dimension. How are we gonna do that? Ah, okay. Okay, did everybody see that? So we know, this is a rectangular prism, right? So we know that the volume has to just equal x plus 5 times x plus 1 times whatever.
So first, would you like, combine the x plus 5 and the x plus 1?
No, we wouldn't want it, because if we leave it like this, we can just divide through synthetically twice.
Oh, okay.
You see, because the first step would be like, we'll divide both sides through by x plus 5, for example. That's gonna give us a smaller polynomial over here that we could divide by x plus 1, right? So really, I mean, all we have to do is just do the nested synthetic division. We'll just go through the process twice, and what we're left with when we divide both of those away is the missing factor, right? Yep.
Will it matter which term you started with?
Wouldn't make any difference. Wouldn't make any difference. Yeah, we know that those, based on the nature of this problem, those have to be factors, don't they?
Right.
Right. Okay, so let's do this. What are the coefficients?
3, 8, -1, and -3.
Okay, and we're dividing in what? Negative 5. Okay, and that has to be what?
Zero.
If it's not 0, something's wrong. Okay. So we bring the 3 down.
-7.
35. Okay, so it worked, right? So that guy's gone. Now we'll repeat the process. So what goes out front this time? -1. Bring 3 down, -3, -10, 10, 0. So what's the missing dimension? 3x minus 10, isn't it? Right? Right there. That should be. Make sense?